this time if you just want information on Unit 1. AP Statistics changed their rubric for the 2027 exam, so there's a few topics that were removed, a lot were shifted around. Now there are only 5 units instead of 9, and so I'm just going to be restarting from scratch, making 5 videos for each of the units, maybe some practice videos, going over everything again, anything that's changed. I'll be going over all the calculator functions that you need for AP Stats, and then also some other ones that are useful in general for an intro to statistics course or just working with data in general. For Unit 1, there is nothing that you explicitly need for the AP exam. You're never really going to be given data and having to work with it or asked to generate random numbers, but it can be useful to have these things and know how to do this in Desmos in case maybe you have a project in your AP Stats class or you just are needing to work with data in general and you want to do it in Desmos. To start off, we have making lists. So a list is just a group of numbers inside brackets. So I could do a list of numbers 1, 2, 3, 4, 5, 6. 6-element list, and you can assign it a variable. So L for lists is one I like to do. L equals, well, this. If I put L into another one, we'll see the same thing pops out, the same 6 numbers. You can also put any arithmetic sequences into a list. So if I wanted all the odd numbers up to 101, I could do 1, 3, and then ... 101. Click on this to view all the numbers, and you can see there we have all the numbers, 1 to 101. You can do this with any starting number, the second number, which was going to be adding your term, and then your final number. If you want just integers, you only need the first number and the last number. So all integers from 10 to 20 is 10 ... 20. And if you are making more advanced things in Desmos, you can also do something like 1 ... n, set n to a variable to have a list of whatever you want. Do note though that lists have a cap of 10,000 elements. If I did 1 ... 10,000, that would work, but 10,001 would not work. Let's see, no more than 10,000 elements. When you're working with a list, I have a list right here, L1, that I'm going to be using to show. And the most important function is the stats function. So stats of L1 gives you count, mean, median, standard deviation, population standard deviation, and 5 number summaries, including a box plot. So this is an incredibly useful function. It does basically everything you'll need just at a quick glance. This actually got upgraded from before. Before stats used to just give this 5 number summary and no box plot. But it's also useful to know other functions in case you want to work on some specific things that aren't here. For example, let's say if you have a statistic that needs the mean and the median, if you can type in the mean function and then subtract the median function from that, and that'll give you that. Or if you need, instead of the population variance, which should be the standard deviation squared, you need the population standard deviation cubed. It's useful to know STDEV, that's standard deviation. If you add a P, it's population, and then you can cube that for your statistic. All of these functions are available if you go to show keypad here. If that's not there, then you can go to functions, scroll down to statistics, and everything is right here. And you can just click on it, say you want the minimum, min, and that'll just appear in the equation or in a new equation if you're already on one. And then you can type in your list to get the statistic there. So another thing that you might want to do is to graph a list of data. The most common one is a histogram, of course. So you can type in histogram of your data set, then click on zoom fit with this little plus in the magnifying glass, and that'll bring it into focus, bring it into frame. The second input in a histogram function is the bin width. So I can change this to 0.5 for smaller bins, or 2 for larger bins. Automatically it'll be set to 1. You could change the alignment. So on center alignment, each bin is going to go from like 7.5 to 8.5, 8.5 to 9.5. On the left, it's going to start on each integer and go to the next integer. So 8 to 9, 9 to 10. But center is the default. You can also use, this is the count, so it'll tell me how many values are in each bin. Relative is going to show me proportionally, so the heights of all these bins will add up to 1. Density will have the areas of all the rectangles of the bins add up to 1, which is the same when the bin width is 1, but when the bin width is 2, again, this area will add up to 1, but if we go to relative, then the heights will add up to 1. So that's an important distinction to make. You can also make a box plot. So if I did box plot of L1, again, zoom fit button, this will show me, the minimum, the quartile 1, median, quartile 3, maximum. You can toggle showing outliers as dots. So without that, this outlier is just counted as the minimum. The height is the vertical stretch factor. So if I change this to 3, that stretches out the box plot. 0.1 makes it really thin. And the offset is just the y value, which the box plot is centered at. So I could change that to 2 or 3 or -2, anything like that. These display properties is really useful when you want to look at a histogram and a box plot at the same time. So let's say I have my histogram and I want relative. We can zoom in on this. And I want to see the box plot at the same time. I could display the box plot below this histogram. So I could change this to -0.1. It's centered right down here. I don't want it as stretched as much though, so I could change the height. And now I can look at both of these at the exact same time, which is a very useful thing to do. There's also dot plots, which represent the data as dots, but especially when you have non-integer values, this gets really messy, and a histogram kind of does everything that you'll need to do with a dot plot anyway, so I recommend just using a histogram and a box plot to do anything that you want to do. The last thing that you might want to do in Unit 1 is random number generation. So the function for that in Desmos is going to be the random function, which with no input generates a random number from 0 to 1, a random real number, I should say. And if you click the randomize button up here, it's going to kind of re-roll every random function that you have in your Desmos graph. You can also, the first input that you have, if you only have one input, it's going to be the number of rows you have. So if I did random of 10, it's going to give me a 10 element list that is 10 randomly generated numbers from 0 to 1. Let's say though, you don't just want to generate random numbers from 0 to 1. Let's say you want to emulate rolling a die. What you can do is instead of putting the number 10 in here, you can put a list that has all your outcomes. So for a dice, that's 1, 2, 3, 4, 5, or 6. And then you can do comma and how many you want. So 10, this is emulating rolling 10 dice, and these are all the outcomes in a list. It's uniformly selecting from all the values in your list. So let's say you want to have a 90% chance of getting a 1 and a 10% chance of getting a 0. You could put 0, 1, 1, 1, 1, 4, 5, 6, 7, 8, 9. So this is going to be 90% chance of a 1 and a 10% chance of a 0. And you can see that's usually what we're getting, way more 1s than 0s. And I could do the same thing if I wanted to emulate from my list. I could put L1 in there. This is 10 random numbers from L1. And you could also do the other way around, where if you do L1, you could do dot random, and then you can just put the number of random numbers selected from that list that you want. So just like so. This can be really useful if you want to find the average of something and you forgot the method how. So let's say I have a list of the dice again, 1, 2, 2, 3, 4, 5, and 6. I can do dot random of some number 100. I could set this value to a list. So this is all my outcomes from randomly rolling 100 dice. I could do the mean of L. You can see 3.62, so that's probably going to be kind of close to the average. Getting around that every time. I could bump this number up to 1,000, even 10,000. It's going to be getting more accurate. And you can see experimentally, we've kind of found the value that we have, which the average of rolling a dice is going to be 3.5. Now we can kind of do that just by estimating it by using this random function.